Hello students. Today's lesson we will be continuing our topic on probability. Now in the last lesson, just as a review, you looked at a topic called theoretical probability. And basically what theoretical probability is looking at the likelihood of all the possible outcomes of different possibilities that could happen in a variety of situations. Now, experimental probability is actually calculated the exact same way. The only thing that makes experimental different from theoretical is that you're dealing with a certain number of trials that you do when you conduct an experiment and how successful you are at achieving certain events. So, calculating the probability, the experimental probability is the exact same way as we would for calculating theoretical probability. We would just simply divide the number of times an event occurs with the total number of trials that take place in an experiment. So let's begin by looking at the first example here. It says, in 20 boxing matches against Lenny, Carl wins 12 times. What is the experimental probability that Lenny wins a match? Well, let's take a look at the situations that we have here. So we have the probability that Carl would win and the probability that Lenny would win. Well, we already know that out of 20 boxing matches, Carl won 12 times. So that leaves us, well, how many matches were left over that Carl would win? Well, if we think about it, we got 12 matches that Carl won, that Lenny won, so that leaves 8 left over that Carl had won. So the answer for our problem would be 8 out of 20. Now, technically, this is correct, but we can simplify that probability down, because if we look, 8 out of 20 does share a common factor with each other, so that simplifies down to the probability of 2/5. Or that's the same thing as, that would be 40%. So that would be your answer for example 1. So let's move on and take a look at example number 2 now. In 30 times at bat, Jan struck out 14 times. So what is the experimental probability that Jan will strike out at her next at-bat? So this is dealing with a certain number of trials. So the probability that Jan struck out is basically going to be the number of times she struck out compared to the number of times that she was at bat, which would be 30. So her experimental probability of striking out would be 14 out of 30. Or we can reduce that down, and that would give us an answer of 7/15. And that would be your answer for number 2. So let's take a look at number 3. So this is a little bit of an analyzing question. It says, you and your friend want to play a game with a spinner, and the table shows the results of 120 spins. And you have to determine from these two situations which game seems fair and give reason for your answer. So if we think about this, we're dealing with a spinner that has 3 different colored sections on it. We've got red, we've got yellow, and we've got blue. And so in this game that is done, the spinner is spun 120 times, and this is the result of the data that we gather from our experimental probability. So let's see if this first game is fair. You win with yellow, and your friend wins with blue. Well, let's compare. So the probability of winning with yellow from our data here is 23 out of 120 times that we spin. Now, again, the reason why we know it's 120 times is because it's what the word problem tells us. And plus, if we add all 3 of these numbers together, it should total 120. Now, that's the probability of winning on yellow. Let's compare that with the probability of landing on blue. So that would be 39 out of 120. And if you were to compare both of these probabilities with each other, there's a big difference between 23 times versus 39 times. So would this be a fair game? I would say that this is not a fair game in this situation because of the comparison between these two probabilities. Now let's take a look at part B. It says you win with red and your friend wins with blue or yellow. So let's do the same thing like we did for part A. We're going to be comparing the probability of red compared to the probability of winning with blue or yellow. So the probability of winning with red is 58 out of 120, okay? Now the probability of that your friend wins with blue or yellow, in this situation, we're going to take both of these into account. So what we do is we total these two numbers together. So if we add 23 and 39 with each other, then that gives us 62 out of 120. Now, compare the results of both of these experimental probabilities with each other. We have 58 out of 20 compared to 62 out of 120. Not much of a difference between the results of both of these experimental probabilities. So since they're both close to being equal with each other, we would consider this to be a fair game because the probabilities are close to being equal in measurement with each other, as opposed to the first example here where there was a pretty stark difference between both of these probability measurements that we were comparing with each other. So that's just a few examples of, just to give you some practice and a little bit of a better understanding of word problems that you would run into dealing with trials of events and how you would use that information to calculate experimental probability. If you have any questions about the topic, feel free to email me, ask me any questions, and I hope you have a fantastic day. Take care.